This is the structure of vanillin, and salicylate from the meadowsweet. This is the structure of salicylaldehyde, as well as cinnamaldehyde, which is extracted from cinnamon. This is the structure of cinnamaldehyde. Ketones are common names of ketone are derived from the naming of alkyl and aryl group bonded to the carbonyl group. In common system, aliphatic ketones are named after the alkyl group attached to the carbonyl group. First method of conversion of nitriles into aldehyde by Stephan reduction using stannous chloride and concentrated HCl. Hello my dear students, I am Renuka Ashok, the Department of Chemistry, Vidhyaashram Pre-University College, the Temple of Excellence, Mysuru. Welcome to the first session of chapter Aldehydes, Ketones and Carboxylic acid. My dear students, in this session, I am going to give an introduction about aldehydes and ketone, nature of carbonyl group and preparation of aldehydes and ketone. So, this chapter I am going to deal with three organic compounds, aldehyde, ketones and carboxylic acid. Today's session I am going to explain about aldehydes and ketone. Now, aldehydes and ketones are collectively called as carbonyl group. Carbonyl compound because of the presence of carbonyl group. Aldehydes are where only one alkyl group is attached, others is satisfied by hydrogen. But ketones, two valencies are satisfied by either alkyl group or aryl group. Therefore, aldehyde and ketones are the organic compound contain carbonyl group. Carbonyl group means C double bond O. Aldehydes are the organic compound in which carbonyl group is attached to one hydrogen atom or one alkyl or aryl group. But in ketones, both are alkyl or aryl. Carbonyl compounds have wide application in nature. They are widespread in plants and animals. They are very important role in biochemical process. They add fragrance and flavor to nature, as well as some of the members of aldehydes and ketones are act as solvent. They are used to prepare adhesive paints and fabric, as well as vanillin. You know that vanilla flavor, it is extracted from vanilla beans. This is the structure of vanillin, and salicylate from the meadowsweet. This is the structure of salicylaldehyde, as well as cinnamaldehyde, which is extracted from cinnamon. This is the structure of cinnamaldehyde. The first structure is the structure of vanillin, second one is the structure of salicylaldehyde, third one is the structure of what? Cinnamaldehyde. There are two systems of nomenclature of aldehydes and ketone. As you know, one is common names as well as trivial name. Second one is IUPAC name. Therefore, in common names of aldehyde, they are derived from name of corresponding carboxylic acid. It replaced oic acid from aldehyde. If you observe branching, they will put first position, will put alpha, beta, gamma. The alpha carbon atom is directly attached to the aldehyde group. The carbon atom which is directly attached to the aldehyde group is called as alpha. Next to alpha, beta. Next to beta, it is called as what? Gamma. Ketones are common names of ketone are derived from the naming of alkyl and aryl group bonded to the carbonyl group. In common system, aliphatic ketones are named after the alkyl group attached to the carbonyl group. Simplest ketone, acetone, dimethyl ketone. It is acetone. The position of the substituents are indicated by the letter alpha and alpha dash because both the carbon are attached to the carbonyl group. Beta, beta dash, alpha, alpha carbon being the ones directly attached to the carbonyl group. So, in IUPAC system, the aldehydes are named according to, so the first number should given to the functional group aldehyde and the suffix is Al. Next numbers are given to the substituents. Next. So, observe this slide have given some important aldehydes, common name as well as IUPAC name. For example, when you consider HCHO, its common name is formaldehyde, it is methanol. CH3CHO, the common name is acetaldehyde, IUPAC is ethanol. My dear student, please go through this slide. Have given some of the important aldehyde, their common name as well as what? IUPAC name. And in case of ketone, same rule. What are the IUPAC rules are applicable for other organic compound? Same rule is applicable for also ketone. But here the suffix used is ONE. Suffix used is what? ONE. Here also in this slide I have given some important ketones with their molecular formula as well as their common name as well as their what? IUPAC name. Now in the both aldehydes and ketone, they contain carbonyl group. The pi bond of this shifted to more electronegative oxygen. Therefore, oxygen become delta minus and it will become what? Delta plus. So therefore, the bond angle, and it is sp2 hybridized, and the bond angle is 120. Bond angle is 120. The oxygen atom has 2 lone pairs of electron which occupies its remaining 2 orbital. The carbonyl carbon and 3 atoms bonded to it lie in one plane, and sigma electron cloud is present above and below this plane. Therefore, in aldehydes and ketone, what's the angle of separation? The angle of separation is 120, as well as expected hybridization is sp2 hybridization. sp2 hybridization. The carbon-oxygen double bond is polarized due to the high electronegativity of oxygen. Therefore, when the pi bond is shifted to oxygen, oxygen becomes negatively charged and carbon becomes partially positive. Therefore, carbon is electrophilic, oxygen is nucleophilic. It is Lewis acid and it is Lewis base. Lewis base. And aldehydes and ketones are prepared by important method. First one, dehydrogenation of alcohol. When you consider primary alcohol, dehydrogenation means we have to remove hydrogen. In the presence of catalyst called heated copper or silver at 573 Kelvin, you will get aldehyde. Similarly, you take ketone, so secondary alcohol, you remove hydrogen, you will get ketone. Therefore, both aldehyde and ketones are obtained by the dehydrogenation of primary and secondary alcohol in the presence of heated copper or silver at 573 Kelvin. Second one, from ozonolysis of alkene. Take alkene and it is treated with ozone, we will get ozonide. This is treated with zinc dust and water. Zinc dust and water. Either it will get only aldehyde, or it gives only ketone, or it gives rise to mixture of aldehydes and ketone. Therefore, ozonolysis, one we can prepare only aldehyde, one we can prepare only ketone, and one we can prepare mixture of both aldehyde and ketone. When you use propene, we'll get a mixture of ethanol and methanol, that is acetaldehyde and formaldehyde. When you use 2-methyl propene, you'll get propane 2-on, or its trivial name is acetone, Next, by hydration of alkyne, take ethyne. Ethyne in the presence of sulfuric acid and mercuric sulfate, it reacts with water, it gives rise to acetaldehyde. Other than ethyne, that is propyne, butane, hexane, that does not give rise to aldehyde, it gives rise to ketone. And one and only alkyne which gives rise to aldehyde when it is treated with water in the presence of dilute sulfuric acid and mercuric sulfate as a catalyst, only one alkyne, that is what? Ethyne, or its trivial name is acetylene. Now, some of the methods from which one we can prepare only aldehydes, that is from nitriles, and this reduction is special reduction is called as Stephan reduction. Take nitrile, RCN, it is heated with stannous chloride and concentrated HCl. First you will get imine. What are imine? When carbon and nitrogen are bonded with double bond, when carbon and nitrogen is connected by double bond, they are called as imine. This imine, which on acid hydrolysis give rise to aldehyde. Therefore, what is Stephan reduction? Was the reducing agent used in Stephan reduction? The Stephan reduction, the reducing agent used is stannous chloride and concentrated HCl. Concentrated HCl. When nitriles are heated with stannous chloride and concentrated HCl, first it will form imine. Imine on acid hydrolysis, it gives rise to aldehyde. Next, alternatively, one we can take nitrile. How can you convert? Nitriles are converted by adding dibal H. What is dibal H? Diisobutyl aluminium hydride. So, first method of conversion of nitriles into aldehyde by Stephan reduction using stannous chloride and concentrated HCl. Was the alternative method to convert nitriles into aldehyde by adding dibal H. Diisobutyl aluminium hydride. Similarly, when you add diisobutyl to ester, it is also converted into aldehyde. Therefore, nitriles and esters are converted into aldehyde by adding diisobutyl aluminium hydride. What are the two methods to convert nitriles into aldehyde? The best method of conversion of nitrile into aldehyde is Stephan reduction by using stannous chloride and concentrated HCl. HCl. Second method of conversion of nitrile into aldehyde by adding dibal H. By adding dibal H. Dibal H. By adding dibal H. Diisobutyl aluminum hydride. Second one, Rosenmund reduction. Rosenmund reduction. Here, how can you prepare aldehyde? By adding hydrogen to acid chloride. Acid chloride. What's the formula of acid chloride? RC double bond O Cl in the presence of palladium supported over barium sulfate. Palladium supported over barium sulfate. You will get aldehyde. Observe, my dear student, learn general equation. Example, in place of R, as I told you, either you substitute methyl or you substitute ethyl. Next, how can you prepare benzaldehyde only? From Etart's reaction. Etart reaction, you take toluene. Toluene is treated with chromyl chloride in CS2. It will form chromium complex, which on acid hydrolysis, it gives rise to benzaldehyde. This reaction is called as Etart's reaction. Like, what is the reagent used in Etart's reagent? Chromyl chloride. Chromyl chloride. Last one, how do you convert toluene into benzaldehyde? By adding acetic anhydride and chromic anhydride, you will get what? Benzaldehyde. Last one, what is the important reaction and compulsory for your board? Gutterman-Koch reaction. Benzene is heated with carbon monoxide and HCl. Carbon monoxide and HCl. In the presence of anhydrous aluminum chloride, it gives rise to benzaldehyde. When benzene is heated with carbon monoxide and HCl, in the presence of anhydrous aluminum chloride, it is give rise to benzaldehyde. This reaction is called as Gutterman-Koch reaction. Gutterman-Koch reaction. My dear student, this session I discussed about how aldehyde and ketones are prepared. In the previous session, I am going to discuss about how only ketones are going to prepare physical property and some of the chemical property. Therefore, next session I will come up with preparation of ketones and properties of aldehydes and ketones. Until that, goodbye, take care, have a nice day. Thank you.